Today I'm taking spectra of microbes, specifically Trichomonas variabilis, which is a cyanobacteria. My research is focusing on preparing for the future search for life on exoplanets. So I'm thinking about the next generation of telescopes, and they will be specifically designed to directly image Earth-like exoplanets and search for signs of life, or what we call biosignatures. These telescopes will observe these exoplanets using reflectance spectroscopy, and this is where we can analyze the light reflected off of the exoplanet surface by its nearby star. The ASD field spectrometer, analytical spectral device. The instrument itself is technically a spectroradiometer, which means it has up to 4 spectrometers inside of it, and each spectrometer measures a specific range of wavelengths. And what's really cool about this ASD is that it's covered in this white reflective material, which allows for effective scattering of the light. Because of that, our examinations will look almost exactly like how the future reflectance from these exoplanets will look like. Of course, the only thing that is different from our measurements and what these telescopes will look at is that we also have to account for like atmosphere and sort of distortion and telescope noise. We're looking at a specific feature called the vegetation red edge or the photosynthetic red edge. And this feature is unique to life. It's unique to photosynthetic life. And I've been looking at how some minerals and abiotic processes, essentially non-life, can look like life through its spectrum. So this is the spectrum of the trichomonas, and this sort of shows us the different spectral features. I can also compare it with spectra that I've taken with other minerals, so comparing the vegetation red edge with some false positive minerals. It's something that hasn't really been explored in the field of astrobiology that could be very important for these future telescopes, and we have to make sure that the design of the instruments is going to account for these differences between non-life and life.